Hello, I'm Jack. Welcome to Practical Programming channel. In this video, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create 3D surface charts with both color-mapped surface and a wireframe on the surface. This wireframe was generated by mapping a transparent square on its unit core grid. In this video, I will use this framework to generate a simple 3D surface based on Sinc math function. As shown here, you can see the surface with the color map and also the white wireframe. Here, I will use the Git tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download the source code used in the last video. In this video, instead of using a command prompt window to start our Visual Studio Code, here I will start Visual Studio Code directly from Windows Start menu. Visual Studio Code here. Select. This is Visual Studio Code interface. Now let's start new terminal window and cd into the code folder. Now we need to make a new directory. Make direct. We call GPU 43. Okay, the new GPU 43 folder was created successfully. Now cd into it, cd GPU 43, and we want to clone the source code used in the last video. Here we, after this command, type space and period. This will place all our source code in the current folder. So we run this command. Okay, the source code download finished. You can check the code. You see our source code already here. Now we want to open this folder from Visual Studio Code. Open folder from code GPU 43. Open this folder. Okay, here is source code used in the last video. Now we start a new terminal window and run the following command: npm install to restore all the package used in this example. Okay, finished. Now all the installed packages are stored in the Node modules folder. Today we want to create a simple 3D surface chart for a Sinc function. As shown here, this is the Sinc function definition. fr equal to sin r over r for r not equal to 0. Here r equal to square root x squared plus z squared, and equal to 1 when r equal to 0. This is the definition of the Sinc function. Previously, we have defined this function in the math.func.ts file. Next, we want to make some changes to the index.html file. From dist folder, open index.html file. First, we need to change header 41 to 43 because this is 43rd video. We also need to change the H1 title here to Sinc surface chart. We also need to replace the input parameter here. This drop-down menu let you select the different square image used for our wireframe. You can see here we have 10 different images to choose from: white, red, green, blue, and black squares. This menu lets you select different color map names. Here we have 11 names to choose from. That's the modification to this file. So we finish the modification. Then we can save this file. Next, we need to make some changes to the main.ts file. From src folder, open the main.ts file. We want to use a new code to replace the content of this file. Since most code for render pipeline and render path have been already included in the chart.ts file, this we implemented in the last example. Here, the main.ts file becomes very simple. You can see here we first introduce the chart with texture from chart.ts file. Then from the surface data.ts file, we introduce simple surface data. This data including our square image texture coordinates. We also introduce a Sinc function from math.func.ts file. Next, we create a new function called create chart. This chart contains several input arguments. First is texture file. This parameter let you select different square image for creating the wireframe. And a color map name let you select different color map for our surface. Inside this method, we call the simple surface data methods. This data using Sinc function as its input arguments. So this simple surface data methods create a vertex, normal, color map, and UV data for our surface. We then call create a chart with texture. Use this data from simple surface data and return this data as the input to this method. This create chart with texture will create Sinc surface chart with both color maps and wireframe. Here we define the default square image. Use the white square 2.png. Here the white square 2 means the line thickness is 2 pixels. We also define the default color map name as jet here. And then we call create chart, the method just implemented here to create 3D surface with the default parameters. This part of the code allows the user to recreate Sinc surface chart with different color maps and wireframe by selecting them from these two drop-down menu in the index.html file. Now we finish the modification to this main.ts file, and we can save this file. Up to now, we have finished all the programming. We can then run the following command to bound our TypeScript code in production mode. npm run prod. Okay, the bound file is created successfully. Now we can click the Go Live link from the status bar area to open Chrome Canary to view our Sinc surface. Click this link. Here is our Sinc surface chart with default jet color map and white wireframe displayed on this page. We can use the camera control and see more clearly. It looks nice and pretty. Here we can change the color map by select different color map name. For example, HSV and cool. We can also change the wireframe color. For example, we can choose this is white. We can choose red. One problem with red is wireframe line is here the line. Different locations have different color. It's not a pure red, even though we choose the red square. You can see the line, the color here looks like green and white, but here looks red. This depends on the underline, the color map color. Similarly, for the green, here looks green, but the other part not looks pure green color. And the blue, you see, this looks blue, but the other part not pure blue. And black. You can see no wireframe anymore. Thus, the totally disappear the wireframe. This black square becomes totally transparent. There's no wireframe. That's one problem associated with our current methods. But we still can get a very pretty 3D surface chart, particularly for the white. The white gives, except for white color, other color is not really pure color. For example, here red. See, we can explain the reason for this issue. Use our shader code. Remember, the inside the fragment shader, the final color of our surface is the sum of texture color and V color. V color is from color map. So for our white square texture, the final color is texture color is white is 111 plus V color, the color map color, the RGB. So the final color is still 111 because any color map component over 1 will be claimed to 1. So the maximum is 1. So the white color plus any RGB color still gives white color 111 here. However, for the other color, for example, red color is 100 is for texture color, but V color is still RGB. The total is 1 GB. It's not pure red anymore. They still have green and blue components. So they give this GB, these two components depend on the location on the surface. So that's why you see the different color on different location on the surface. Similarly, for the green color, texture color is 010 plus RGB. It gives R1GB. So it contains red and blue component. Blue, it gives final color RG1. So they still have red and green components. In particular, for the black color, you see 0, 0, and 0 plus the color map, the RGB, it gives the RGB. This means black color totally disappear. They only show the underlying color map color, so it gives RGB. So that's why you cannot see any black wireframe on the surface. Even though we cannot get a wireframe with a pure color, except for white, using our current methods, we still get a very nice looking 3D surface chart with our square textures. Plus, we can easily change line thickness of our wireframe by replace our square image with different line thickness. If we create our wireframe using the line primitives, the line thickness will be fixed to 1 pixel because currently WebGPU does not allow you to change the thickness of line primitives. Now we have completed this example. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.